Okay.
Yep.
Hello everyone. Welcome to this TripleO understanding and overview session. Hello. Can I go ahead?
Yep.
Yes. My name is Avinash. I have 1.5 year experience in Openstack, and I'm working from HP for the past 6 months. I'm working for HP Helion. And today's agenda is about TripleO. We'll be discussing about the overview of TripleO stack in brief. And we'll going through the understanding of TripleO, why TripleO was used, and the approaches and concepts regarding TripleO. We can also have a hands-on or just a how exactly TripleO works on the IMA environment what we currently have. Followed by the questionnaire. Coming to the TripleO overview, I mean TripleO is a program which is aimed for installing and upgrading and operating an Openstack clouds. Before understanding this TripleO, we need to understand what an Openstack is and why exactly TripleO came into picture with respect to Openstack. So if we have an Openstack environment which is used, to create a stack environment, we need to deploy some number of nodes and all these things. The deployment of this Openstack environment can be done using of Openstack. Maybe in the next few slides, you'll be understanding more details of it, why exactly Openstack is being deployed from Openstack and all these things. So TripleO is a concept. TripleO is literally OOO, OpenStack on an something like deploying an OpenStack using OpenStack. So we'll be using this TripleO to deploy OpenStack components. You will deploy OpenStack using the components of OpenStack. And TripleO is also used as an automation tool. TripleO is also used as an automation tool for continuous integration as well as deployment, all these things. Before just jumping into the TripleO, I just want to give an overview of what exactly a OpenStack is. An OpenStack is an open source project for cloud computing. In this test all the data centers as well as we can use that for the production environment in the data center. On the right side of the page or the presentation, you can see a diagram, a rough architecture of OpenStack, which was older one, but which explains all the projects, main projects present in OpenStack. Something like dashboard. It is one of the project which is a UI for OpenStack, that is Horizon. The other one is something like network, which is a Neutron project in the OpenStack, which take care of all the networking related stuff in OpenStack. Similarly, compute. Compute is one of the project stack. Its name is Nova. This Nova takes care about all the VM provisioning and lifecycle management related to virtual servers and virtual machines. One more project name is Glance, which acts as an image, image as a service. This takes care about all the image we are using in OpenStack. Similarly, we have other things like object storage. With the code name in OpenStack is Cinder. The identity is like authentication, authorization. All the users and tenants in this OpenStack is handled by identity. This is a small brief of all the components in OpenStack. We had projects in OpenStack, Neutron, Glance, Cinder, Horizon, Heat, and Iron. The reason for explaining all these things is to have a complete OpenStack, we need all these components. A component like we need a keystone for doing authentication and authorization of users and tenants. We need a Nova project or in component to handle the life management of a virtual machine, starting from creation or instantiation of a virtual server to actually creating a virtual machine. So we need a Nova. Similarly, we need a Neutron component. So all these combinedly form an OpenStack. So to deploy this OpenStack, for example, I'm showing here another slide, a couple of nodes, which is known as network node, compute node, and controller node. A cloud controller node consists of the management related APIs and services that are present in this OpenStack. Before going ahead, is there any queries till now? You can interrupt me in between. If I'm going fast, you can just ask me to slow down. I'll just yes.
Any question so far? Okay. So if you have questions, you're on mute. If you don't have, we assume we can move on.
Sure. If there are no more questions, then I'll just go ahead. Okay. I just mentioned in this diagram with 3 nodes. One is a network node, one compute node, and controller node. All these 3 nodes, we can still have nodes for storage or shift node, storage node. All these nodes, each node will be like a device or a machine. It's not a virtual machine. It's like a physical machine or a bare metal machine what we have. Each node different components and services running on there. For example, if you take a network node will have a DHCP server running. It will have an L3 agent running on it. It will have an OpenVSH plugin agent which will be running on it. Similarly, compute node, the services and components that are running on a network node would be different services and components that would be running on a compute node. So for the compute node, it needs a different set of configuration, a different set of the RPMs or different packages what we need. Similarly, a controller node is a management API, so it has some different set of services and components, something like Nova API, Nova Scheduler, Nova Conductor, Keystone, Neutron. All the API requests that you send to OpenStack Cloud will actually reach this controller. Depending upon the request what we are sending, that request will be processed to network node or compute node, or it will be processed inside the cloud controller node itself. So to deploy these things, network node with so-and-so services and components, or to deploy compute node, so-and-so, and to deploy controller with different n number of services, we taking care of all these things. We should first take care about the nodes and networking between, the networking between the network node and compute node, the networking between this network node and management node. Similarly, the external network, we have to take care of networking related stuff, all the configurations inside these nodes. So this hectic job can be simplified by using OpenStack on an OpenStack. What we exactly do is create a small OpenStack environment where we create each node or each compute node and each controller node as an instances to the smaller OpenStack environment. I'll be calling that a smaller OpenStack environment as Undercloud. From the Undercloud point of view, we will instances. Those instances will be actually acting as a compute node and a controller node that would be given to the end customer. Okay. Maybe I'll just show about what the Undercloud and Overcloud is. We'll just see the advantages of TripleO. The TripleO increase the reliability of deployment and configuration changes. As in the previous diagram, what I mentioned here is each node, each network node, and each compute to be deployed. We deploy that and the GLAN service inside each node, those changes will be taken care by TripleO. A person no need to check and cross-check all the IP addresses. Everything will be taken care by TripleO. That's the increased reliability of deployments and configuration changes. Other one is continuous integration and continuous delivery. Until this TripleO came into picture, before TripleO came into picture, in the OpenStack development, OpenStack is a cloud community where there are 1,600 plus developers who would be implementing a code for OpenStack, and there'll be, a small part of code for OpenStack projects, and they'll be sending their patches into the upstream OpenStack. But before TripleO, there was no testing done. The testing will be done only for a smaller part. So, for example, if I develop a small component, a small feature in a networking component, I would be writing some tests which are specific to that networking component, but as a whole, I may not be testing the deployment of whole OpenStack and how it behaves. But with introducing of TripleO, there is a continuous integration and continuous delivery which was integrated and which will be running at the upstream code. So whenever you submit any patch that will be running in a continuous integration, and you will be easily finding out the bug that would actually arise in production environment. I mean, we may not figure out all the bugs that come in production environment, but most of the bugs which known till the production environment can be known with the introducing of this TripleO. Other one is complexity in handling installation upgrade. This complexity has been reduced by using this TripleO. For example, I took an OpenStack environment which is of Icehouse release, and the upcoming after 6 months, a new release of OpenStack is being released, something like after 6 months, a new release of OpenStack is released, something like Kilo. To upgrade this process, previously it used to take a hell lot of time, and there dependencies and all this would happen. But with the introduction of TripleO, this complexity in handling this upgrade process has been reduced, and the operational maintenance cost, there is no need of those, the maintenance cost also has been reduced with the invent of this TripleO. If we take a normal approach, consisting from this provisioning to orchestration, in the sense we'll be selecting the list of bare metals. For example, data center has 5 nodes, and I want to install OpenStack, or I want to create a cloud environment on these 5 nodes. So I need to analyze what is my controller, what are my compute nodes, and networking node. If there are any block storage nodes or object storage nodes, I need to identify these nodes, and after identifying those nodes, I need to this software on it, a software in need to install an operating system on that, and install all the packages that are required for the specific node. Say an example, we have a node B, C. We have 3 nodes. Let's make it simpler. We have only 3 nodes. One is a control, 1 and 2 compute nodes. I'll just go back to the figure. We have 3 nodes. One is controller, which will be having a list of services like Glance API, Glance Neutron server, and a Nova conductor, Nova scheduler, Nova API. These list of services, the code for this or the packages of these services has to be only on a controller, and the packages of compute node, compute specific node, has to be installed only in a compute node. So that software part is the second part, and the third, configuration. The configuration that really comes, what does in the configuration we do is we modify config files of Neutron, we modify the config files of Nova. Similarly, we modify the config of each and every with respect to how exactly they needs to run. On a compute, the compute node has to know what exactly the controller is. So a Nova compute running on a compute node should be integrated with the Nova API. So these the of this controller has to be known by this compute. So we'll make some configuration changes in the Nova compute that the Nova API is actually running on. So similarly, we have lots of parameters where we need to make some configuration changes in Nova, and after making the configuration changes, we need to service of Nova. This configuration changes is a config part, what is actually here, and the state. The state is something like whether currently the state of process is running or not. For example, if the process is currently dead, or if I'm actually rebooting a machine, process will be dead. I need to make the configuration similar to the configuration what exactly it has started before. That state will be actually and those changes are being kept in the configuration file, and again it will be executed. And this process will begin again. And the orchestration. Orchestration is a list of processes, or the list of glues all the components what all to be executed first. For example, I'll just say an example of orchestration. Yes. Is there some query?
No, I think you can go on. From time to time you are breaking, so I don't know if you are moving, but from time to time you are breaking a little bit.
I'm not sure, but I mean, actually not moving, but I'm not sure whether the signal was low or something was actually happening here.
Very recently it was okay. It was just maybe 10 minutes ago, 5 minutes ago. I think you can go on.
Okay, fine. Sure. The orchestration is like all the components, what all to be executed first, and what all parameters that it has considered while doing all these things. Here we use a heat orchestration, which does and all these things. This was a normal actually done before, and now the TripleO, after invention of TripleO, it will be a single API and all these things. But inside the single API, we have different fields which take part of each thing. From the cloud operator perspective, he will be doing 2 or 3 commands which internally will take place of all these things. The first one is bare metal or ironic. This bare metal or ironic is a new project in Openstack which is used for bare metal installation. For configuring bare metal as an instances. Include that. Maybe I can just give me a minute. I'll just show how exactly that bare metal works. This is a normal scenario. OpenStack controller having here, OpenStack controller running here. When the end user want to install a virtual machine, he'll be request a controller to install a virtual machine. The controller process the request to the compute node, to the available compute node. Virtual machine will be launched on available compute node. This virtual machine is a part it's a virtual server which was running on one of the compute. Now this is a normal normal virtual instance created in an OpenStack. Now coming to bare metal is something like I have a controller or which bare metal compute installed in this, and if I want to create a bare metal instance, it's not an instance. These are actually the physical nodes what we have. So controller, I will be sending a request to create a instance, or we create a bare metal instance. So this will be sending a request to bare metal compute running here, and that will be processing that request to ironic components or ironic project. Then I will actually send a PXE boot or if me request to this bare metal and power off the and reboots and send PXE request, DHCP IP, everything from this, and a VM and a instance or an system is actually installed in this. This is similar to how we actually create a virtual machine, but the virtual machine is created on top of compute node where KVM there was will be lying here, but here there is no there will be a bare metal hypervisor which says that this instance what you create here is actually a physical machine in virtual machine. This is what exactly ironic do. So we uses this concept from a controller. We will be launching few bare metal instances. These bare metal instances will be actually acting OpenStack controller or OpenStack compute node what we have. So the configuration what we want to make in this will be taken care of fields what we mentioned here. This disk image builder, this bare metal ironic is used to create such bare metals. The instance in the previous diagram, this ironic bare metal which I'll actually created those bare metal instances. This image disk builder will includes the image, or for example, I already said to you that this TripleO is also used for continuous integration and continuous delivery. So whenever a new creep in, I need to generate new image. So this disk image builder will take care about all the changes that needs to be made in this disk. And after making these changes, this OS apply config and OS refresh config. These are OS template configs which are present in this Git repository of OpenStack. Are used for applying all the configurations whenever reboot has happened from the template. I mean, we'll be mentioning the the IP addresses, what are the interfaces that we have that we want, and what are the range what we want. From those templates, a configuration will be applied, and this heat will be taking care of all these orchestration things. For example, this heat, I'll be creating a bare metal, and I'll be saying to take an instance of bare metal, so and so image. After that, do the deployment of this configurations, all these things, and this heat take care of all these things of creation of bare metal images in that, and deploying those images into that instances, and applying those configuration and creating a controller node itself. This is the TripleO approach what we have. Now, if we say what I'm exactly here is, we have this. I mean, we putting all the list of packs starting or will deploy in something like installer kind of thing. Okay, let me put this way. I mean, our main aim is to deploy OpenStack and provide that OpenStack environment for the end users. So once I create an OpenStack, so I will be having a list of tenants. I mean, I can create a list of tenants in that, and each tenant I can provide some resources to the tenants, or the tenants can, depending upon their usage and request or their usage and their requirement, those tenants will configure the respective virtual machines. So our main aim is to give them an OpenStack environment. That OpenStack environment is this Overcloud what we have. But to deploy this OpenStack, this Overcloud OpenStack environment, what we are using is Undercloud. I mean, we are using one more OpenStack environment. That OpenStack environment is running in this Undercloud. From this cloud, we are launching bare metal instances. So the instances that are launched this Undercloud will be bare metal instances. Bare metal instances, as I already mentioned before, it is not a virtual machine. It is actually a physical machine what we want to configure. So before actually configuring this Overcloud, we'll be creating bare metal instances from Undercloud. So Undercloud will be doing this Overcloud controller, Overcloud compute nodes, Overcloud shift nodes, whatever the requirement what we have. So these configurations was done. So the networking between these, I mean, there should be a networking between this controller and compute, controller and shift. So this networking, everything was managed by the networking of this OpenStack environment what we have. So the configuration changes, all these are done based on golden what we have. Okay, golden image is something like a basic raw. Okay, for example, if you want to install in Ubuntu, if I start from the basic raw image or something like ISO, it takes at least a half an hour of time to process everything. But what is a golden image is, it's like a, I mean, it's like a basic image, a base image what we have. So just, it's something like a base image. If we just, after reboot of a machine, there is no need of installing any operating system every time, because an operating system is already present, the base of operating system is already present in the machine. So we'll use such base to install these bare metals. Cloud will be having these base images, and we're using those base images, we'll be configuring these Overcloud controllers and compute nodes using this bare metal instance. Before actually, I mean, an Undercloud. So I'm saying that to install an Overcloud OpenStack, I'll be needing an Undercloud OpenStack environment. But be someone who needs to install this Undercloud OpenStack, that thing will be done by a seed. But I mean, in this Overcloud OpenStack, what we have a huge number. I mean, it is what we actually give to the end customer. So it has a full stretch OpenStack environment. But this not a full-fledged OpenStack environment. This is a minimum OpenStack environment which uses just Nova and Neutron and a glance for retrieving of base images and an Ironic project or Ironic components to install these bare metals. But apart from that, it's not a full or a full or complete OpenStack environment. So it doesn't take much of the fields. From the seed, we'll be just passing what are the things for this undercloud deployment, and the undercloud deployment will be done from the seed. If we go into details of each and every, what is a seed? A seed is acting like an installer. So the seed is used to create an OpenStack environment of undercloud. So it's not a OpenStack environment. It's a minimal OpenStack environment which has the processes of glance and heat with Ironic also. I mean, all this are from the seed environment or from the seed mission. We will be creating an undercloud. This was created using Ironic, but the orchestration was done using heat. Heat will be saying on which bare metal this has to be done and what is the instance IP range and all this orchestration details for that, and what is the image that I have to take to launch undercloud bare metal instance. Once that was done, then it will be up and that would be up and running. Again, undercloud is the same process of deploying. It's the same words what I say. Undercloud is like a deployment and management cloud. So this undercloud OpenStack environment is not a full-fledged environment. It is just used for deployment and management of cloud, which is actually the overcloud, which is actually given to the end users. So this undercloud uses the physical machines to be created as instances of undercloud. It uses Ironic driver to install this instances of control and compute node on that. And not, as I already mentioned in the previous slides, to have an OpenStack environment, we might be having a controller, a compute node, and lots of nodes. But this is single node, a basic installation with only one node. That is what undercloud, which is running here, and that is used just for deployment, testing, management, and update, and all these things on Overcloud servers or Overcloud OpenStack nodes. What we have. So I mean, this undercloud also has few logging and monitoring components which are used to monitor what all exactly happening on Overcloud nodes. We have Isinga, we have Eon services. I mean, the different services. I mean, I'm just saying about HP proprietary ones. We have all these services which are running on this undercloud. Once the undercloud orchestration is done, then an overcloud comes up. This overcloud is a full and feature-rich OpenStack installation. Overcloud is what an end operator actually will be creating a tenants and overcloud OpenStack environment, and these tenants will be creating virtual servers, and they'll be using that. We'll be providing web interface of Horizon. I mean, I think so. And the web interface, we're already aware of that. This is a functional cloud available for end users for running guest virtual machines and workflows. I'm just reading those things what are present here. And this overcloud consists of a number of controller nodes. I mean, I already mentioned we have a compute network. So this overcloud consists of all the nodes, the controller nodes, the compute nodes, and storage nodes, and all these nodes are actually present on this overcloud. And this is a full and fill-rich OpenStack installation. So it has all the compute nodes, all the compute processes, all the networking processes, block storage required, all the OpenStack. I mean, all the complete of OpenStack services will be up and running in this overcloud. Maybe any more queries still here? I mean, hello.
Any question? If you have, you are on mute.
So far, so good.
Okay, you can go on. Avinash, you can go on.
I mean, this is about how exactly a TripleO works. Okay, thank you. How a TripleO works, a TripleO actually starts from a seed or installer. An installer will be triggering how to install, what to install in a basic, simple, single node OpenStack that cloud. So from TripleO, the whole thing will be moved to this Undercloud, where it will store all the images that need to be launched or an Overcloud. All the networking will be done by this OpenStack environment of Undercloud. And from this Undercloud, a new more bare metal instances will be created. Those instances are the Overcloud controllers and compute nodes. This is the actual concept of. I'll be just showing from the environment what we have, how exactly this TripleO will be working, or how exactly it was actually deployed in the current environment what we have. IMA environment setup what we actually have here. Are you able to see my screen?
Not yet. It's painting really slowly.
Yes. These are the credentials of host machine, or this is the IP. I'm just logging to the seed host machine.
Nothing is painting yet, so maybe you should wait until we can see.
Sure.
Are you sure you are sharing? Because what we are okay, it's coming. I think it's coming slowly. I will tell you.
Network here is very slow, I suppose. Can you see this? Okay, I'll just
not yet.
Brown color maybe for better. Connection.
Okay, now we see a blue desktop. Yeah.
Yes, on that a putty would be running.
Yep, we see this.
Okay, can you see the putty now?
Yep.
Okay.
And we see the login screen.
Still logged into the putty. Okay. Can you see the white screen putty now?
We see another login screen.
Okay. Maybe I'll change the background to white screen. Maybe I don't know why it is very slow that show you this background. Please see the putty.
So what we see now is the change settings that you are trying to do.
Okay.
Okay, we see your white window.
Okay. This white window is the host machine. Okay, I'll just go back to the slide once again to explain that or to link seed VM or all those things. You can see my presentation, isn't it?
Yep.
On this presentation, we have a seed which is Undercloud. Undercloud is the actual bare metal instance, which is an OpenStack environment, and this Overcloud is another OpenStack environment that would be given to the end users, and all this controller and compute are bare metals. This seed part, what's speaking here, is actually a virtual machine. This is not a physical machine. This is just a virtual machine. This is just installer. So we'll be creating a virtual machine on any of the available nodes what we have. So I'm actually logging into this host node of this virtual machine right now. Okay. This white background. Can you see this machine? Isn't it now?
Not yet, not yet.
Not yet. Okay.
So just for the logistics side, we have 10 minutes left maximum because we have another session later on, and I want everyone to be able to have a small break if possible.
Okay, sure. I mean, it'll up in 5 minutes. It's not just a demonstration of whole thing.
Yep. So we are not seeing your
if there is
screen
no
yet.
problem, yeah. If there is no more problem, then just complete this in 5 minutes and just give it. Is it okay?
Yep. But we are not seeing your white window.
Okay.
Not yet.
Okay, fine then. Maybe in the next session or after the end of next session of Horizon, maybe I can show you these things.
Yep. Okay. So are you saying that you don't want to show us what you were planning to?
Yes. Maybe some of you can present that, or can I see? I mean, my side it was opening, but I'm not sure.
We see your screen now.
Okay. You see this that was running here. I mean, hello.
We see your white window.
This is a seed host machine. What we have on this host machine, we already have a seed machine or a seed VM. This seed VM is the actual installer. So I am logging into the seed VM. So now I already logged into the seed VM. I hope you can see that I logged into root at /Linux. Is it visible now?
Yep, it is.
Okay. This is a normal OpenStack environment which actually launches and if I using a Nova command, I'm displaying the instance of this OpenStack environment. Instance shows a normal an OpenStack environment which has one instance, and that is an Undercloud instance.
Wait,
okay?
It's painting. We are not seeing yet. We just see
Undercloud.
We just see the Nova list command, but not the result. Yeah, now it's coming. Yep.
Okay. If someone can try from the other end, I can just say the commands also, or I'll just send out the commands also. You can just
please.
see.
Yeah.
This Nova list will display the instance, and this is an Undercloud instance which was running in this seed VM. So I'm just logging into the Undercloud.
Mm-hmm.
I just logged into Undercloud now, and I'm sourcing the credentials of Keystone. So from Undercloud, I will bare metal instances of Overcloud. So my machine will be having a lot of controllers, computes, as well as storage nodes. So I will be instances is Undercloud. So if you see the Nova list in Undercloud, you can see a lot of nodes. Is it visible now?
Not yet.
There's something like Nova compute. Not yet. Okay.
No.
Okay.
We just see your SSH command now.
Oh, It's very slow, that means. Maybe I'll just send a list of stuff. Maybe that would actually give you a break before the other session. You have other session maybe in under 10-15 minutes.
Yeah, if you can anyway send me both your slide and the list of comments that you are using at the end. Maybe just add one slide with a list of comments at the end of your slides. That would be good enough.
Sure. I'll just send the list of commands slide and just send us the slide. In between, if you have some more queries, you can just ask me now. Maybe somewhere which is not that much clear or something, or somewhere where I should pass something.
Any question? Sorry, sometimes we had some issues with the connection, but we hope we could get most of it. Is there any question?
No, most of it is clear. I think we are okay.
Okay. So Avinash, I want to thank you for this. So please send directly the slides to me and all the details, and I will be making sure that everyone attending will get those details. Okay?
Fine, definitely. Thank you, Stephen, and thank
by
you
the way,
for attending this.
Yeah, we now see all the Nova Compute. We see them now.
Okay, fine. It's not a problem. I'll just send a list of commands along with the presentation slide. The session presentation.
Okay, good.
Fine. Thank you everyone for attending this.
Thank you very much.
Thank you very much, and talk to you in 10 minutes.
Yep, see you soon.
Bye-bye.
Thank you. Bye.